and welcome to the event Fast Action Mitigation to Slow Warming in this Decisive Decade.
Good morning. I hope everyone had a chance to get their coffee because we're going to hit the science hard. All right, can we get the science slides, please? So thank you for the introduction, Dreyfus, Gabrielle. I'm the other Gabby, if you know Gabby Levy by any chance, she's over there. I'm the chief scientist with the Institute for Governance and Sustainable Development. Are we good to go? There we go. There's me. That's Rick. He's coming later. Stay tuned. All right, let's hit the science. I got it now? All right. So, why are we here? That's actually a deeper question that science can't answer. But the world is warming. And this is a figure from the second IPCC Working Group 2, so the Adaptation and Vulnerability Report. There's a lot of data on it, but what it's really telling us is that we are facing not one, but two climate catastrophes at the same time. Crises. Sorry. We do have people. It's actually useful to have people in front of the slides because people is what matters here. We like to show a lot of graphs, but what this is showing us is that the world is warming. We're already around 1.1, 1.2 Celsius above pre-industrial. We are very likely to cross 1.5 C in the early 2030s. That's what these curves here are showing, the dotted lines. And if you take that horizontal dotted line at 1.5 across those what are called burning embers diagrams, those scientists are very creative, called those reasons for concern. And you can see that already at 1.5, we're in the yellow to red zones across the 5 reasons for concerns. The closest one is extreme weather and unique and threatened systems. The second one is extreme weather. If you listen to the news, you will be aware that climate impacts are happening today. When I was learning about climate science in grad school a while ago, climate change was something that was going to happen in the future. In the last 10 years, climate attribution science has really shown us that the impacts and the severe impacts that we're experiencing today are already due to climate change. And this means that we need to slow warming today, because the severity of those impacts is only going to increase with every fraction of a degree of additional warming. And if you go all the way to that most reason for concern, that is irreversible tipping points in the climate system that we know, and there's a paper that came out at the beginning of September that assessed about 200 papers of literature. There are systems, so my background is a paleo climate, so I study how the climate changed in the past. We know that the Earth's climate has changed in the past. We were not there for the big changes as civilization, and there are irreversible tipping points in the climate system that we may start to trigger beyond 1.5. And so this is why we need to slow warming today. So this is a paper that we wrote. I was one of the lead author on, that came out in the Proceedings of the National Academies in May. And what it tells you is that, yes, we need to decarbonize. That is the orange curve. Focusing only on CO2, phasing out fossil fuels as a singular focus, while essential to stabilizing climate in the long term, because carbon dioxide has a long life, it is a slow carbon cycle, we're talking geological timescales, and when you burn fossil fuels that contain sulfur, you actually co-emit reflective aerosols. So as you turn off those CO2 sources, you do turn off CO2, yes, but you also turn off those reflective aerosols. And those reflective aerosols are currently masking about 0.5 degree. And so if you only do decarbonization, you actually increase the rate of warming. So on the left, so this is for the scientists among you. The left graph is temperature. The right graph is the rate of change of warming. And that orange graph, the orange line on the right side, you actually see it increasing. So the rate of warming actually increases in the near term if you only decarbonize. And the way to turn that curve, to slow warming faster, the only way to do that through mitigation solutions is by also intentionally targeting methane and other short-lived climate pollutants that are super potent in terms of far more effective at trapping heat than CO2, and shorter lifetimes, meaning if we start cutting methane today, we can start to see the impacts within this decade. So it's decarbonization day, but we're here to say it's decarbonization and. that we need to do to keep 1.5 alive. So this is a graph from the IPCC Working Group 1 report that came out August of 2021. What it's doing is turning the individual contributions of all these climate forcers into the temperature contribution since the pre-industrial. CO2, do I have a pointer on this thing? Does that? Anyway, CO2 is about 0.7, 0.8 degrees C. But what I have in the orange boxes are those short-lived climate pollutants. And when you add those up, you actually have about half of the positive warming contribution that we are experiencing today is from these short-lived climate pollutants. Methane is about 0.5 degrees. The net warming, like I said, 1.1. So yes, it might be short-lived, but if you keep emitting a short-lived climate pollutant that is super potent, it's going to heat things up. And then, so that shows that there, and then nitrous oxide, don't want to forget nitrous oxide, not short-lived, but also super potent. Actually, one more point on this slide before I move on. When you cut these short-lived climate pollutants in the near term, you actually get 4 times more of the avoided warming by 2050 than CO2 alone. Again, this is not an either-or. This is a both-and solution, because we got to stay alive, keep 1.5 alive, so that we can do the marathon to decarbonize. Again, this is from the recent Climate and Clean Air Coalition Global Methane Assessment Baseline Report. Came out just a week or 2 ago. Highly recommend you check out this report because we need to know where we're going. And what this report is looking at is what the potential is. These figures are showing the potential from the combination of decarbonization and targeted methane mitigation. The figure on the left, that black line, decarbonization alone. Warming in the near term, but you turn the corner. You gotta decarbonize. If you pair it with a short-lived climate pollutants, in particular methane, you see you bring down that near-term warming, and you actually get 2 times the near-term benefit. The figure on the right, yes, decarbonization, guess what? Methane is a major component of natural gas. You will get some methane abatement if you decarbonize, but only a third of what the potential is. You got to do both. The figure on the right side is showing you if you target methane intentionally, what you can get. And it's significant. Again, you got about 0.2, 0.3 avoided warming potential by 2050. So what is our trajectory absent that intentional focus on methane and other short-lived climate pollutants? The black line here shows this baseline assessment. Based on existing policies and trends, we are actually set to add 13% more methane. That's just anthropogenic methane. I'm not even talking about natural feedbacks. Unless we, again, I'm using the word intentionally. So this will not happen by itself. A lot of people like to point to IPCC scenarios for keeping 1.5, which says you got to decarbonize, you got to cut the short-lived pollutants, and you got to pull carbon out of the atmosphere. Well, those things don't happen by themselves. That's why we're here. You know, we humans, actors, we got to make choices. So baseline emissions, if we do nothing, methane actually goes up. Blue line is constant, just for reference. Green line is what we want with the Global Methane Pledge. GMP, Global Methane Pledge, 30% reduction relative to 2020. How do we get there? Marcella's going to tell us more about the specifics of this, and my panelists are the solutionists. But the way we get that 150 million tons of methane to reach our target is we have to cut emissions from agriculture, waste, and fossil fuels. Those are the major sectors that contribute to methane emissions. And fossil fuels here, while it is about total human methane emissions, agriculture and fossil fuels are similar in magnitude, but fossil fuels has the biggest potential. There is there's a lot of methane that is leaked and wasted in the fossil fuel sector unnecessarily, and we can tackle that first, and a lot of that is low-cost options. So at least half of the control measures that have been identified, again, Ani started by saying we have solutions, essentially pay for themselves or come very close. All right, more graphs. I told you I was a scientist. More figures. So this is another of a short-lived climate pollutants. We've been talking a lot about methane, But hydrofluorocarbons, this is what's in your car, your refrigerator, your air conditioning, and your heat pump. Love heat pumps. Come talk to me afterwards. We want to talk heat pumps. It runs on refrigerants, hydrofluorocarbons, and the blue big blob is what would have happened absent agreement by all countries in 2016 on the Kigali Amendment to the Montreal Protocol on substances that deplete the ozone layer. There was an agreement. We're now on that orange curve if we do everything. So the left side is emissions, the right side is temperature. If you take anything away from this talk, emissions distinct from temperature, because it depends what you're emitting. And so time, temperature, pollutant. Those are the three things I want you to take away from this. And what we have so we have essentially that 0.4, 0.5 degree avoided warming between the blue and the orange, thanks to the, pink, they updated it, to the Kigali Amendment. So we have success stories, right? We can do this. And we need to start tackling these sources of emissions. Back to methane. We, with satellites and other technologies, have a much better capability now to see methane. I don't know if anyone's seen methane before. Our eyes aren't good at seeing it. But with special measurement sensors, we're starting to see sources of methane like this. This is Turkmenistan. These are leaks, mostly from the infrastructure around oil and gas extraction. This is taken from NASA's EMIT instrument, which is currently on the International Space Station. And so we start to see these things, get a wrench out. This is what we need to fix. And with that, hopefully took away time matters. We're facing two climate catastrophes. We need slow warming now. Methane and short-lived climate pollutants essential to slowing warming in the near term to keep us alive. So the way we like to say it is we are in a sprint to cut short-lived climate pollutants so we can slow warming now, so we can stay in the race for the marathon to decarbonize, to stay alive. Keep 1.5 alive.